What? No, no. Okay. Section 3 in Chapter 1 reviews transformations of functions. It also reviews combining functions or different ways to combine functions. So that could be with addition, subtraction, multiplication, division, or composition of functions. So the section as a whole is new functions from old functions. So how can we take a function and then make a new one? We're just going to review transformations this morning before your homework quiz. And like I said, I do have something that kind of lays out as a guide for you the different transformations, but I want to see what you remember. Some of these we already talked about. So remember I said in AP, you cannot always use a calculator. So when you have a calculator, you can use your calculator to graph a function if you want to see what the graph looks like. But if it's a no calculator part of a test and you see a function written out, understanding the transformations and what or how to kind of sketch that graph by hand would be helpful to you. So that's kind of the reason we're going through this. So first of all, on your sheet, I'm just going to put up here, sketch a graph of f of x equals x squared. Just make a sketch. It doesn't have to be like specific points plotted. Just sketch what would that graph look like. Can somebody tell me what it should look like? Parabola, vertex should be where? At the origin. Okay. Now I'd like you, so we're going to be graphing transformations of x squared. So now I'd like you, we're graphing all of these. I'm not going to keep rewriting graph. Now graph g of x equals x squared plus 3. So try not to make a table if you need to make a table to help you remember what that transformation does. So you're kind of asking yourself, what does that plus 3 do to the graph of x squared? All right, what does the plus 3 do? Moves it up. So it's a translation when you have a value added or subtracted outside of that original term or added onto it, subtracted from it, then it is a translation up or down, a vertical translation. So that would move the vertex up to 0, 3. All right, what about this one? H of x equals the quantity x plus 3 squared. So we have another plus 3. What does this plus 3 do? Yeah, this one moves it to the left. So anything that is happening inside with the x, then that is going to be a horizontal transformation of some sort. So if there's a number being added to or subtracted from x, in this case, inside that quantity squared, it's going to be a horizontal translation, left or right. And horizontal things always are the opposite of what you think they should be. This looks like it should go to the right, it goes to the left. So now the vertex would be at 3, 0. I'm also going to write on here another way to express this. Maybe I'll use a different color. I'm going to go back up to number 2. So remember, x So if you see things written like that, or h of x, this would be written like f of x plus 3. So it's like you're substituting x plus 3 in to the function x squared. So just so you see that notation as well, what's kind of happening there. Yes, sorry. Thank you. All right, next one. I'll use m now. M of x. I'm gonna run out of letters here. 3x squared. So what does that 3 do? Well, amplitude would be like specific to trig functions like sine and cosine. I think you have the right idea. Okay. Yes, it is either an expansion or a compression. And I'm not sure how, did you use the phrasing like compression, compress or expand, compress or stretch? You could say stretch also. So, yes, when the number is multiplied on the outside of the function, so the number is not multiplied by x and then squared, it is a vertical stretch or compression or expansion or compression. So if it's 3, is that going to be an expansion or compression? Expansion, yeah. So this would be a vertical, I'll write it out here. This would be a vertical expansion, or you could say stretch. So the origin is still the vertex, but now it would be skinnier. Okay, so then this could be written this way, m of x. This is equivalent to saying 3 times f of x. So the 3 is multiplied outside of the function. Or a way to think of that is you're multiplying all of the y values then by 3. So if it's changing the y values, it's vertical. So then this one, I'll use n of x. So what if it was the quantity 3x squared? Okay, it's going to be horizontal because the 3 is inside with the x. It's opposite of what you would think it would be. So because multiplying by 3 vertically was an expansion or a stretch, if you multiply by 3 or a number greater than 1 inside with the x, it's horizontal, but it's a compression. And it's the way that it's written also. So this would be equivalent, if you simplify this is equivalent to 9x squared. So if it was written as 9x squared, you would call that a vertical expansion or vertical stretch. But if it's written as the quantity 3x squared, the 3 has the transformation of making it compress horizontally. So if it compresses horizontally, it is stretching vertically. But based on how it's written, that's how you kind of categorize what stretch or compression is happening. So then this actually would be even skinnier than the one I drew above, but still narrower than just x squared is the idea you want to get here. So this could be written as n of x is equal to f of 3x would be that comparison with f of x, or using the f of x notation to write that out. Okay, and then 2 more if we have negatives in here. So let's see, I'll use p. P of x is negative x squared. What does that negative do to the graph? flips it upside down. Yes, so reflects over the x-axis is the way you'd want to describe that. So if it's written this way, it's a little easier to see maybe. The opposite of f of x is the way I could write that. So it's showing that now all of the y values are opposite, and if the y values are opposite, that is a reflection over the x-axis. So then this is the last one aside from one I'm just going to have you sketch that as multiple transformations going on. I'll use r here. R of x is, what if it's the quantity negative x squared? So what does that negative do if it's inside? The graph is going to look the same, but what is happening? Yeah, so if it's outside, it's a reflection over the x-axis. This is making all of the x values the opposite, which would be a reflection over the y-axis, but because x squared is an even function, it's just going to look the same. I didn't hear what you said. If it had a transformation left to right and it was negative, would that make a difference? No, because, okay, this brings up a good point. That's a good question. Let me just write this before I forget. So this would be r of x is f of negative x. So you're asking if it was like negative x squared, and then you also had, like, if it was the quantity negative x plus 3 squared. That's what you're asking. So, yes. So when you have multiple transformations, you work through, or rather you sketch those transformations in the order of operations. So that is the order you should follow. So I will say for quite a few graphs you might sketch, whether or not you follow order of operations, sometimes you still get the same looking graph. But Dan was just asking if you had something like, I'll just use f of x again. If you had something like negative x plus 3 quantity squared, you'd want to do the multiplication first by -1. So you'd make x negative first, you'd reflect it first, and then shift it to the left 3. So it would look the same as if this was positive x plus 3 quantity squared. Okay, so then if you have room somewhere, I just like you to sketch one other one. Let's see, what letter can I use here? We'll use T. T of x. So negative or the opposite of the quantity x minus 2 squared minus 4. Sorry. So make a sketch of that, and then we'll check if we all made a sketch of the same graph. Yeah, don't graph it on your calculator first. The whole point of this is if you are not allowed to use the calculator, because if you are, you would just graph it on your calculator. Okay. For this one, I didn't lose my sheet. You are right. I'll stop the recording right now. Thank you. Alright, I will show this. You can double check for parabolas. I would say you do want to make sure in this case with transformations that your vertex is in the right spot, or you could locate what ordered pair the vertex is at. So the vertex should be at +2, -4, and it should be opening down. So by order of operations, you would start in the parentheses, shift it to the right 2, then you would reflect it to be opening down, and then it would be shifted down 4. Okay, but like I said, sometimes without following, you might still be able to get that same graph by chance, but sometimes if you're not following it, it will look different. So what I just passed out to you then is what they have laid out in your textbook as well. So it's just kind of the formulas that explain the different transformations. And that is why when I had written these underneath in blue, that's why I wrote them that way, so you could kind of compare them to what's on here. And there are some that maybe we didn't quite go through because like we went through a horizontal compression, but not a horizontal expansion or stretch. So it gives the vertical and horizontal shifts, the translations here, so if you're adding or subtracting a number on the outside or inside of a function. And then it gives the stretching and reflecting, so showing if you're multiplying by a number, it does say C is greater than 1. So number greater than 1, fraction, either inside, outside of the function, the different reflections. And then the last thing I want to show you that you may not have seen before, another transformation is taking the absolute value of an entire function. So it has a similar definition as the absolute value of a number. So if you remember the way that we had defined the absolute value of a number x, we said it's equal to itself. So the function, and remember the function is representing the y values. So the function is equal to itself as long as f of x or the y values are greater than or equal to 0. But then it's equal to the opposite of itself. So the y values are opposite if they are less than 0. So that's how it's defined. It's a very similar definition to just the absolute value of x. But I have in words what this means. So it means that if you sketch a graph of a function, the part of the graph that lies above the x-axis, all of those y values are positive, they stay the same. The part that lies below the x-axis, those are negative y values, those get reflected above or get reflected over the x-axis so that in the end, all the y values are positive. So just to show you here, I'm just going to sketch a graph that would be partially above, partially below. I'll stick with a parabola. Say, it doesn't matter where you draw it. Say you had this parabola, okay? I'm going to try to color code this, then maybe it'll help. So when I draw, say this is just y equals f of x, and now I'm going to sketch y equals the absolute value of f of x. So this part and this part will stay exactly the same because those pieces are above the x-axis. This piece will be reflected above the x-axis. So this part stays, this part gets reflected, this part stays. Okay, so you're just taking anything below the x-axis and reflecting it above. And that would be a transformation of taking an absolute value of an entire function. Okay, just making all the y values